with standard, the international something, which means, see, if you tell me something, let's say Nabeela, if I ask you the length of something, length of a rod I have asked you, and Nabeela says it is 1 meter, and I say it's 100 centimeter. I have measured it's 100 centimeter, but Nabeela says it's 1 meter. So it isn't different. She is saying 1 meter, I'm saying 100 centimeter, means both of our answers are actually right and both of us are giving the same answers. But there are various units that are existing. What if, Hafsa, you come and answer, you tell the answer in millimeters, the measurement of the same rod. So like this, there will be confusion with so many system of units. That's why a standard has to be chosen. That standard is chosen by this SI system of units, and they choose the standardized, like for length, meter has been chosen. So whoever is answering the length has to answer everything in meters. Final answer has to be given in meters. That is the SI system. And one more unit, you have CGS system. In CGS unit, you just give an answer a little lesser value of the SI. Like meters, we have centimeter. Kg, we have grams. But time remains the same. Now, in our SI system, we have 7 fundamental quantities and 2 supplementary quantities. So these 7 fundamental quantities we will be discussing right now, and the 2 supplementary, that also means. Now, when we are talking about these 7 fundamental, the first one that you have is mass. Just a minute, just a minute. Okay. Yes. So the first system that we have is the mass. Now, class, whatever we'll be discussing here, that will be used in the dimensional formula also. We'll write the same thing in the dimensional form. So when we talk about mass, see, mass is represented
Ma'am,
with
what is
the
dimension?
M. Yes?
What is dimension?
Dimensions mean, see, you must have heard of 1D, 2D, 3D, these terms. Those are actually the dimensions. Dimensions means the measurement of the physical quantity. So dimensional formula we write in order to depict, like if I say something is there, 7 kg is present. So this has the dimensions of mass. And if I tell you 10 meters, then immediately in your mind it will come that this is the dimension of length. Means it's the unit or depiction of length. So for different physical quantities, we have different dimensions. Some dimensions are given in 1 dimension, right? When only 1 coordinate is present. Some are given in 2 dimensions. In the plane, some are given as 3D, 3 dimensions. When we say 1 dimension, usually we represent it for length. 2 dimensions become length into breadth. 3 dimensions means length into breadth into height. Like the dimensions just tell about the physical quantity's nature. But dimensional formula is just a formula to write that mathematically. You cannot explain the 7 kg and 10 meter concept all the time. So what you do, you just construct a dimensional formula. So everybody who is present, they are going to see that dimensional formula and they'll just have a standardization. So did you get this, Hazza? What is dimension? Dimension is just a measurement or depiction of physical quantity. Okay. Who is this Humaira? Humaira, you're for the physics class.
No, ma'am. I am. I have to do. I have to join maths class for Arshi ma'am.
Okay, Arshi ma'am's class. Okay, wait. Humaira, your maths class has been cancelled for today.
So the same class is scheduled for tomorrow. Okay, Umaira?
Okay, ma'am.
So see, Hafsa and Nabeela, yeah. So the representation of mass is M, like this. And SI unit we write is kg. So you need to remember the SI units, because see, when you will enter the numericals of physics, you will find there are various different quantities that are there. Various quantities are there. So you should know. See, kilo is there right now, kg, grams are there. When you will see the numericals, you will find microgram, nanogram, picogram, megagrams, like these. So you should know which is the SI unit. So it's kg. Now CGS means, CGS stands itself for centimeter, grams, and seconds. Okay, centimeter, grams, and seconds. So this is what is the CGS. It's just that, see, one standard unit is fixed, that is the SI. This system has been fixed. Just one level lower system is also fixed, just in case if we need to convert. Because every time just choosing one unit will not help when there are multiple units present, right? So that's why we have kilogram. And for CGS unit, we have grams. Similarly, length is represented by a capital L. SI unit is meter. Okay. Centimeter is the CGS. Time is represented by capital T, but SI unit is the same in both of them. You don't use minutes here or seconds. No, seconds. For SI also it's seconds, and CGS also it's. Class, these three are very important. Entire dimensional formula that we'll write after this. This is just the introductory part of dimension. Because we are just now getting introduced to the physical quantities. You should know what are these: mass, length, time, okay, and what are their SI. So it's very easy right now. Now see, temperature we'll be doing in the second book. I told you thermodynamics, thermal physics. Remember we discussed these thermal things will come in the second book. So temperature is represented by theta, or in some books you will find it represented as capital Q. Why? Because the SI unit is Kelvin. So SI unit is Kelvin present. So that's why the SI means the symbol for temperature is not T. Okay, T is for time. Temperature is K, Kelvin. But theta also you can find it in your some of your books. So that's why theta also have mentioned, because when you go to different books, when you refer to different books, somewhere you can find it as theta. And degree Celsius is the CGS unit. Okay. Then we have the electric current. Electric current will come in class 12, but you can need it in your 11th some of the questions also. So it is represented by A, not with C, not with I. Why? Because the SI unit is ampere, and ampere is represented by A. That's why this is the electric current unit. Now till temperature, just remember the CGS and SI both, because this is the part of your class year. The rest of it are not very important for you to remember, but you should know. That's why we'll be just discussing the basic units. That's it. Luminous intensity means amount of light that is coming from a body. Like if a tube light is on here in the room, the tube light is on. So how much intense the light is? Is it dim? Is it overshooting? Like it's very high. So the SI unit for light or luminous intensity is candela, represented by CD. This is represented by A, this is represented by A. And lastly, you have amount of substance. So class, for amount of substance, you have the full chapter of first chemistry, molar concept. There you will study amount of the substance in detail. So these are the fundamental quantities that are present. These are the 7 fundamental, means these quantities don't have any formula to represent them. They will be represented in the different quantities. Yeah, Hafsa.
Ma'am, mole value is 6.022 multiplied by 10 raised to 23.
That is Avogadro's number. That is the number of molecules, not moles.
Okay.
Mole is the smaller unit, And when you multiply number of moles to this value, which you said, that constant is called the Avogadro's number. Then we get the number of molecules. Okay.
Okay.
Okay. So class, please write it till here first. Then we'll discuss the supplementary quantities. Till here, I hope both of you have written. From fundamental, you have to write. Please start writing. Use the chat box. Tell me done. When both of you will say done, I'll scroll it. Is it clear till here? Nabeela, Hafsa, both of you?
Yes, ma'am, it's clear.
Oh.
Ma'am, finish.
Yes, ma'am.
Ma'am.
Yes, Hafsa.
Ma'am, this 7 fundamental as these now physical quantities.
7 1 is?
These are 7 fundamental now.
Yes, yes, yes. These are the 7 fundamentals, right?
Ma'am, finish.
Done, ma'am.
All right. Okay, now as I told you, we have these 7 fundamental plus 2 supplementary. Supplementary means additional. Means main are 7, but you have 2 extra. So what are those 2 extra quantities? What are those 2 supplementary? See, one is plane angle. So see, plane angle you are already familiar with. Till now, till class 10, you have been drawing plane angle by yourself. What is a plane angle? The angle that is formed in 2 dimensions. When 2 rays, they are intersected, they subtend an angle, which we write it as theta. Sine theta, cos theta, your entire trigonometry of maths class 10th was based on theta. So that is what is your plane angle. And how we represent it? This is represented by this symbol theta, right? We have been using and you all are already aware. Now, do you know the unit of angle? Anyone? Any idea? Have you ever heard of it? Unit of angle? No?
Mm.
It's radian. Okay? This is radian. Angle also has a unit. We don't use it. We have never used it before. Now, when you come in class 11th, you will be using this radian unit often like this. RAD. This is how you will be representing it. You will use this radian a lot in your, especially in your rotation chapter that is completely based on this unit, radian. Till class 10th, we never used radian for angle. The angle was just 30 degree, 40 degree, 50 degree for it. Then the second quantity is the solid angle. Okay. Solid angle means, see, the angle that is formed in 3 dimensions. Like if I take a cone, think it like this. See, if I have this, okay. So look, this part that is present, this angle of a cone, if you are able to see, look, this part. Can you see a 3D angle is formed already here? Here, this part. This has a 3-dimensional angle, yeah? Now, this is
Yes,
not
ma'am.
2D. If I want to draw it on the sheet of paper, it will be so difficult for me to draw, right? But see, this 3D part which is present is actually called as the solid angle. Means the angle which is formed in 3 dimensions. So, like this. If the best example is you take the example of a cone. So, this is your solid angle. Now, how do you represent it? Represented by, you will see the symbol omega. This is called as omega. Omega is written. And SI unit is, see, radian was for the angle. Just add STE, steradian. Okay, steradian is the angle of the solid. Now, solid angle isn't used much. This isn't used, but focus on the radian. Radian you shouldn't forget. And one more thing, we were discussing derived physical quantities. What were these derived physical quantities? These were the quantities that were formed by the fundamental, right? Or by different quantities. When you multiply, divide, and you make a new quantity, you get a derived quantity. Like if I give you an example, let's say F is equal to MA. So this F, this is what? This is the force. Or let's say speed is equal to distance upon time. So we are dividing. You can express speed in terms of distance and time. You can express force in terms of mass and acceleration. So these force, this velocity basically means speed. We'll be doing it in kinematics. Or you can take velocity, acceleration is equal to velocity by time. So you can express acceleration in terms of velocity and time. So this acceleration, this becomes our derived quantity. Like this, numerous derived quantities are present. So this is the introductory part. You should know the basics. Now we'll come to how to actually write the dimensions in dimensional form. So write it and just in the chat column, just type done. So I'll get to know that you have completed and then I'll scroll it. Okay, please start writing from here. These are the supplementary points.
Do we write the derived physical quantity as well?
Yes, yes. Write that too. Okay, let's continue. Hafsa, you've written?
Yes, ma'am.
Okay. Now let us see how do we actually write the dimensional formula. Okay. So look, the basic structure of dimensional formula is, see, we'll be writing everything in terms of MLT, like, okay, we will use the fundamental quantity. But see, most of the fundamental quantities can be solved with the help of MLT. If we need temperature, if we need current, we will use. Okay, then we will use. But right now we are going to use MLT. And then there will be some power, m to the power l, x, l to the power y, t to the power z. Something will be. What is this? I'll explain you. So see, what is m? M is the mass. What is l? L is the length. What is t? T is the time. Now, how do we write everything in terms of this? Any quantity comes and how we have to write the basis of the dimensional formula is MLT. So look, the area is written as the general formula of area. You know, it is length into breadth, correct? Now, length, we have to choose out of the 7 fundamental quantities. So, length is represented by capital L. Breadth is also represented by capital L, right? Length is length from the table. But what is breadth? Breadth is actually a length itself. So length and length. So what do we get? It becomes L square. Now look, how do you actually represent the dimensional formula? The dimensional formula is written as C. You can write and leave it as L square also. This is also correct. Or now see, there is no mass, there is no time. So how can we write it? M to the power 0, L to the power 2, T to the power 0. Now look, we have got everything on the basis of MLT, and now we know it has 2 dimensions of length, L into L. So it is giving us idea, it is something related to meter square. This is something related to meter square. Got this?
Mm,
Look,
yes.
let's see the next example. Let's say volume. Okay, if we are talking about volume. General formula of volume that we know is length into breadth into height, right? This is the formula, length into breadth into height. So see, for length we have L. For breadth we have L. For height, what should we write for height? Which fundamental quantity will go well?
L.
L only. Right. Length only will go. So see, our dimensional formula will become L cube, or you can write this as m to the power 0, L to the power 3, T to the power 0. Both are valid. Let us see one more example. Density. Anyone who remembers the formula of density? Any idea of density's formula?
Ma'am,
Yes, mass.
kg by meter cube.
Yes, mass by volume. This is the formula. Mass by volume. So mass is what? How do we write the
Cube
mass?
also there, na? Ma'am,
That is the unit.
yeah,
If you are telling
volume.
that is the unit.
Yes, yes, yes.
Yeah, this is the formula. Unit is correct, kg per meter cube. So see, for mass, we write this m, and volume we have studied just before, it is L to the power 3. Now, when this L will go up, the sign will change. So this will become m L to the power minus 3. So you can write your answer like this, or see, from the formula MLT, we have everything now. M to the power 1, because nothing is given, it means 1 is there. L to the power minus 3, and T is not present, means T to the power 0. So this is how we write the dimensions of density. Tell me, in these three examples, in these three, area, volume, density, are they clear to both of you?
Yes, ma'am.
Yes.
Oh, so please write them. Then we'll see a bunch of quantities after this. Done?
Yes.
Okay. Now see, we are going to start with some of the quantities. Okay. Some out of these you should remember. Okay. At least 5. I will tell you which to remember. Just remember them. And now we'll practice lots of quantities. Okay. Which are there in your syllabus in your NCRT book. So see, distance and displacement. Now, one thing I'll tell you before we proceed with this. See, you will see various new terms and various different formula will be present. And most of the things you will not be aware of because they are from your portions of class 11th and your 12th. So class, don't worry about what is the meaning of each term, how is the formula written, and why are we using this term and that. No. See, your task is just if you have the formula with you, you should be able to write the dimensional formula. You know the formula, you should just write the dimensional formula.
Ma'am,
Yeah, Hafsa.
dimension formula will be easy if we know the derivation. How to find?
Derivation? No,
Like,
no.
dimensional, if you use SI unit, then we can find that.
Yes, if you know the SI unit, exactly. If you know the SI unit, it will be very easy to. That's why we'll be doing the units together. Yes, Hafsa,
Okay.
you're right. With the units, it will always be helpful. Like if you see, she told initially that the densities unit is kg per meter cube. So kg per meter cube is very easy to relate with m by L cube. So with units, you can always relate. So units we'll be doing and you have to focus on units. But don't focus on how to write the formula, what are the meanings of each term. Why am I saying this is, for every term, you have proper chapters throughout your 11th class, throughout your 12th class, you have to do these chapters, right? So all these chapters will be done in detail. And at the end of the session, you will be able to write the formula also by yourself. You'll be able to understand the meaning also. Right now, if we waste our time understanding what is the meaning of each, how we write the formula, then what will we will do later, right? We have to focus on the formula. Which formula? Dimensional formula. How to write the dimensional formula and the writing of the SI unit. So we are starting with distance and displacement. So displacement, basically a little overview myself I'll give you. So formula is length. Distance basically means the distance covered, means the path covered. And displacement means the shortest path covered. So dimensional formula for both of it will be L only, capital L. SI unit is meter, CGS unit is centimeter. Then we have speed. Speed means how distance is changing with respect to time. Now, you have two terms. One is speed, one is velocity. Both are the same. See, when distance changes with time, we get speed. When displacement changes with time, we get velocity. Now, what are the details of these and all that we will see later. So, speed or velocity is simply you should understand distance divided by time. So, how to write the formula? Look, this t will go up. So, see L. Now, this has the power 1. So, it will become t to the power minus 1. So, how do you write the formula? M to the power 0, L to the power 1, t to the power minus 1, like this you can write. Or if you wish, you can leave your answer L, t to the power minus 1. Now, what's the unit? Meter per second. CGS unit is centimeter per second. Now, let's try acceleration. Nabeela, you try this acceleration. What is velocity's dimensional formula? Look.
Velocity,
We just did before.
distance, sorry, displacement by time.
Dimensional formula, Nabeela. Dimensional formula.
Of velocity,
Yeah, of speed and velocity. What is it? What
I
are we doing?
mean,
What is dimensional formula? How do we write?
M0
Yes.
L1 T minus 1.
See, Nabeela, when we are
that's
talking about the
volume.
dimension,
I wrote that as volume.
this one, what we are studying no, here right now, this one. This is the dimensional formula, okay? This is called as the dimensional formula. This is what we are
Of
studying.
velocity,
So for velocity, we just did right now. Look here, I showed the screen also, no, so that you could see from here. Distance divided by time. So when t went up, it became lt to the power minus 1. What was it? This was the dimensional formula of speed only. Got it?
Yes, ma'am. Yes, ma'am.
So see, lt to the power minus 1 is the dimensional formula. And as Hafsa said, we can write m to the power 0 also, and you can omit that also. Both are there. Divided by time. Now look, when this t will go up, this has the power 1 right now. So when it will
Become
go up,
minus
it will,
2.
yes, it will become minus 2. Minus 1, minus 2. Minus 1 becomes minus 2. So this is the dimensional formula for acceleration. The units are meter per second square or centimeter per second square. Let's try one more. Nabeela, now you try. Okay, now you try. How we should write so that you understand writing. Momentum means amount of motion in a body. We will see this later. What is momentum meaning?
Amount of
Motion means, see, uh, take one example like gun. When you shoot through a gun, what happens? The gun recoils back. That's why when you shoot, you put the shoulder. Why? Because the momentum is so much, the amount of motion within the body is so much that it tends to move. Or whenever you are also walking, you cannot stop immediately, right? You have so much momentum in your body. Just a minute. So when we're talking about the amount of motion in the body, means see, if you are running very fast and you want to stop immediately, you cannot stop yourself. You have to slow down and stop because you've gained so much momentum inside you, so much amount of motion is there in your body. That is what is momentum. Okay, Nabeela, try this. See, it's mass into velocity. So for mass, what should I write?
kg, m,
Dimensional formula, not unit. Nabeela, you try.
m,
Hmm?
ma'am, m.
M, right. And what was velocity's dimensional formula? Look, it's written on the screen right now also.
Yes, ma'am. T minus 1.
Yes, LT minus 1. So see, mass into velocity. Now when we multiply, we get m LT to the power minus 1. Now, Nabeela, you have understood this dimensional formula's concept?
Yes,
Okay.
ma'am.
Look, the just it has closed to reshow. Just a second, class. Just wait for a minute. This minus. Yeah. So I was discussing that the momentum's dimensional formula is kg, mass is kg, velocity is meter per second, and cgs becomes gram centimeter per second. Now one more we'll discuss. Hafsa, can you try this? Force is mass into acceleration. For mass, what should I write?
m.
M. And the acceleration, do you remember?
Meter by second time square.
So dimensional formula, not unit. I'm asking dimensional.
Yeah, yes, ma'am.
Huh.
It's force.
So it will be
Fifth number will be
acceleration. What is acceleration's dimensional formula?
m multiply
Acceleration's
acceleration
dimensional formula, Hafsa. You told me the unit. How do we write the dimensional formula? This is acceleration. What is the dimensional formula of acceleration?
m l t raised to minus 2.
Where is m here? Is there any m?
M by raised 0. You can
Yes,
write, ma'am.
m will be 0. So L t to the power minus 2 is the dimensional formula for acceleration. So L t to the power minus 2 So we can write this as mLT to the power minus 2. This becomes the complete form. Now force has the unit Newton. So you write it as capital N, or you can write this as dyne also. This is the CGS form. Now look class, you know velocity accelerations were used everywhere. So force, this one, acceleration, speed, and distance, obviously. These should be remembered by you. Okay, learn them after the class. Because you know, once you will know these, your entire calculations will become very easy. Write it till here first. Please write it properly.
Okay.
Done, both of you?
Yes, ma'am.
Hafsa, you have also written?
Yes, ma'am.
Okay. Class, time is up. We'll continue from here in the next class. I'll share an assignment with you. Okay, so try to solve that. And class, look here. Till fifth one, whatever I have marked, try to remember and practice whatever questions we have done. Whatever you have written in your notebook, just try to practice them so that in the next class we can complete the other quantities also. All right, and if you have any doubts, you can.
Ma'am, when will be the next class?
Next class, just someone from the operations will tell you. Okay, operations from the management. Okay,
No, ma'am.
okay, just contact them once. They'll tell you
Ma'am,
that.
class is only 1 hour. Can we increase the hours of
Yes, yes,
class?
the duration will be 1.5 hours for one class. Just